Up to this point, we've seen three different ways to make a primary amine. The first one was using potassium phthalimide. And of course, you make the potassium phthalimide from phthalimide. Right? So we take that and we treat it with potassium hydroxide. So we make the potassium phthalimide, and then we treat that with our alkyl halide, and then it reacts via an SN2, nucleophilic attack, loss of leaving group. And then you remove this whole portion of the molecule using the hydrazine. And so you incorporate your nitrogen to make your primary amine. You can also use sodium azide to make a primary amine. So sodium azide, you have to know how to draw the Lewis structure of the azide ion that's shown here. So again, it's just an SN2 reaction. So you have your nucleophilic attack, loss of leaving group, right? And then the hydrogenation reduces that down to the primary amine. And keep in mind that you can also reduce, so in step 2, you could put or lithium aluminum hydride followed by water, either one. And then the last one that we looked at was the reductive amination. So reductive amination is where you could use ammonia as a source of nitrogen, and you use sodium cyanoborohydride, catalytic amine of acid, and you get your primary amine. So, when you take a look at these three reactions, the nitrogen from the primary amine comes from the potassium phthalimide in the first case. It comes from the sodium azide in the second one, and it comes from ammonia in the reductive amination. So we have three good ways to make a primary amine. And what's nice about being able to make a primary amine is that you can now use that to make a secondary amine or a tertiary amine. And the best way to do that is to use reductive amination, okay? And sometimes students will say, well, why do I have to do a reductive amination here? Why can't I just do alkylation to go from the primary to secondary amine? And the reason why is you would get polyalkylation if you did that. So the take-home message is once you've made that primary amine, if you want to make a secondary amine or a tertiary amine, the best way to do that is using reductive amination, and then we could do an alkylation to make a quaternary ammonium ion. Okay, question 22.16. Using ammonia as your source of nitrogen, show the reagents you would use to prepare each of the following amines. Okay, so the nitrogen is going to come from ammonia, NH3, and we're going to have to form this carbon-nitrogen bond and this carbon-nitrogen bond. So this part of the molecule is going to have to come from this aldehyde, so 2-carbon aldehyde, so that's acetaldehyde. And then this part here is going to have to come from this aldehyde. Okay, so there you go. That would be 3,3-dimethyl butyraldehyde. Anyhow, so there's all our starting materials. It doesn't matter which one we do first. We could start with this aldehyde, or we could start with this one. I'm going to start with the blue one. So we're going to start with our aldehyde. So there we go. There's our aldehyde. And we're going to treat it with ammonia and a catalytic amount of acid. So we'll put catalytic amount of acid, sodium cyanoborohydride, and of course our ammonia. Okay, that does our reductive amination. So now we've installed our amines. So 1, 2, 3, 4. There's my amino group. So now I'm going to add the other 2 carbons. And so for that, I'm going to need my 2-carbon aldehyde, my catalytic acid, and my sodium cyanoborohydride. And so now I will have added those extra 2 carbons. So there's my nitrogen. Now I have a secondary amine, and there you have it. Okay, in B, again, the nitrogen is going to come from ammonia. Okay, and the rest of the molecule, all this portion here, okay, if you can permit me to do a retrosynthesis out here, that's going to come from this ketone, which is cyclopentanone. So this one, there's only one alkyl group anyway, so it's pretty straightforward. So we're going to start with our cyclopentanone. We're going to treat that with, I'll put the acid first, our catalytic amount of acid, our sodium cyanoborohydride, and our ammonia. And there you go. That's going to give us our product, cyclopentylamine. Okay, and for C, again, our nitrogen is going to come from ammonia. This portion here is going to come from cyclopentanone, so you can see why I left the answer to the previous problem up, right? And then these two groups here are methyl groups. They're both going to come from the same molecule. They're both going to come from formaldehyde, okay, the simplest possible aldehyde. There we go. So the first step is already written out for us. It's the same as it was in the previous example. So now we're going to do a reductive amination. We've got our primary amine, so we're going to treat it with catalytic amount of acid, sodium cyanoborohydride, and our formaldehyde, like that. That's going to put one methyl group in. So now we've got one methyl group, and then to install the last methyl group, we just repeat the conditions that we had before. Our catalytic amount of acid, our sodium cyanoborohydride, there we go, and our formaldehyde. And let me finish drawing my aldehyde, and that's going to give us our product. I'm kind of running out of space here, so I'm just going to clean up some of this retrosynthesis here. And there is our final product. So this would be what? NN-dimethyl cyclopentanamine.